Hello everyone. So in this video again we have come up with a very interesting question pertaining to series in general or cubic series. So let's take a look at the question. Find the sum of all positive integers n such that when 1 cube plus 2 cube plus 3 cube plus dot 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 n cube is divided by n plus 5, we have the remainder as 17. So let's take a look. Here we have the series 1 cube plus 2 cube plus 3 cube plus dot 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 n cube. So basically sum of cubes from 1 to n is actually given by the formula n square n plus 1 square by 4. Okay, so this is when this number is divided by n plus 5, we get remainder 7. Okay, so there must exist, this actually means there must exist a number q such that n plus 5 into q plus 17 is equal to this particular term in general, which is n square n plus 1 square by 4. Okay, so if we can further write this as n square n plus 1 whole square equal to 4 n plus 5 q plus 4 into 17. I hope this much is clear. So n square n plus 1 whole square is basically, if we just consider this part, because this is basically divisible, completely divisible by this part. So now if we consider this particular part, basically 4 into 17 equal to 68. Okay, so this is the condition when mod n plus 5, we are dividing by the same self. But again n square n plus 1 whole square given by minus 5 square into minus 4 square, 400, when it is divided by n plus 5. Now simple, we have substituted the value in here, 5 square n plus 5 and n plus 5, we have just substituted the value in this particular case. Thus n square into n plus 1 whole square is congruent to both 68 and 400, which implies n plus 5 divides 400 minus 68 equal to 332. This is again enter 2 square 3. Now as n plus 5 is greater than 17, the only choices for n plus 5 are 83, 166 and 332. Okay, now checking three cases verifies that n equal to 78, 161 work, but n equal to 327 does not. So therefore the required sum is 78 plus 161 equal to 239, which is our answer. So hopefully the methods involved in particularly solving the question is clear to you. So we have gone in details describing all the steps as in how we can go about while solving this particular sum in general. Do one thing, you can actually try the sum on your own with this video as a reference for the same, so that you can get a better understanding on the approaches involved towards solving the same again. So this is one of the ways. So if we talk about there's one more way to actually solve this particular sum as well. So let me just show you that it's a little different approach towards tackling this question. So let me just take a look. Let me show you how that way it works. Suppose let me take m equal to n plus 5. So therefore what we have therefore basically n will be equal to m minus 5. Okay, so here we have 1 cube plus 2 cube plus 3 cube plus dot 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 plus n cube. We can actually write it as m minus 5 square, m minus 4 square by 4. So remainder is given away, so mod m will be 17. Okay, so if we split this particular term up, we have m square minus 10m plus 25 into m square minus 8m plus 16 by 4. Okay, mod m equal to 17. So with that said, let's take a look at this particular term itself. Suppose I am to divide this m. Okay, let me just elaborate this one more step so that things become a little clear to you. This can be written as m to the power 4 minus 8m cube plus 16m square minus 10m cube plus 80m square minus 160m plus 25m square minus 200m 200m plus 25 into 16 is 400, and I am taking this 4 4 4 4 4. So mod m equal to 17. So this and all entire term, if we take a look at this particular term when divided by m would give remainder 0. Similarly, this will also give remainder 0, another 0, 0, 0 again, 0, 0, 0. Only in this case we will not have a 0. So we can actually neglect all these terms and just focus on 400 by 4 itself. So basically 400 by 4 mod m is equal to 17. So here basically we can further write this as 100 mod m equal to 17. So therefore m can be, the value of m is basically 87. Oh no, not 87, it should be, my bad, 83. Okay, I hope it's clear. It can be further, if we take a look at the values itself, it can again be something like 166, and finally double of that, 332. And now we basically check the cases for each and every one. So we just put the values of m in all this and see if we are getting the conditions, whether they are satisfied or not. And when we do that, we see that for this value the condition is satisfied. For this we'll basically put it over here, okay, and we'll see whether the conditions are satisfied or not. So so this value satisfies the condition, this value satisfies the condition, but from 332 onwards, the multiple of 83, the value isn't satisfying the equation itself. That is, we are not getting 17 as a remainder. So our possible value for m, our possible value for m are 83 and 166. Therefore n would be 7, sorry, my bad, n would be 78 and 161. This is basically coming from this particular equation, getting n from here. Okay, I hope it's clear. Therefore required sum is equal to 9, 13, 3 to 39. So this is another way of solving this question. So you can opt for either of the methods, so whichever you feel comfortable with. So this is another approach towards solving the same. So hopefully things are clear to you, then the steps involved towards solving this question in the second method itself. So you can opt for either method, whichever you feel comfortable. You can actually try this sum in that way itself. So with that said, we have come to the end of the video. Hopefully everything is clear. So I'm signing out now. Thank you so much.